Good morning, student. Today we discuss electrical properties of solid. On the basis of electrical properties, solids are of three types. I repeat again. On the basis of electrical property, solids are of three types. The number one is conductors. The solids with conductivity ranging between 10 raised to power 4 to 10 raised to power 7 ohm inverse meter inverse are said to be conductors. For example, metals and their alloys. I repeat again. The solids with conductivity ranging from 10 raised to power 4 to 10 raised to power 7 ohm inverse meter inverse are said to be conductor. Example, gold, silver, platinum, etc. Number 2 is semiconductors. Semiconductors are those solids with conductivity ranging from 10 raised to power minus 6 to 10 raised to power 4 ohm inverse meter inverse. Semiconductors generally are of two types. First is intrinsic semiconductors. They are pure type of semiconductor. Example, silicon, germanium, etc. And the second type is extrinsic semiconductor. They are obtained by mixing impurities in intrinsic semiconductor. Examples are N-type and P-type semiconductor. I repeat it again. The solids with conductivity ranging between 10 raised to power minus 6 to 10 raised to power 4 ohm inverse meter inverse are said to be semiconductors. They are of two types, intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductors are pure type of semiconductor. Example, silicon, germanium, etc. While the extrinsic semiconductors are those which are obtained by mixing impurities to intrinsic semiconductors. Example, N-type and P-type semiconductor. It is interesting to note that the conductivity in semiconductor is due to jumping of electron from valence band to conduction band. The third type is insulator. Insulator are those solids with conductivity ranging between 10 raised to power minus 20 to 10 raised to power minus 10 ohm inverse meter inverse are called insulator. As the name indicates, they are poor conductor of electricity. Examples are plastic, wood, etc. They are poor conductor of electricity because they have no free electron or they have forbidden zone in between valence band and conduction band. Now let us consider conductivity of electricity of metal in metals and semiconductors. It is interesting to note that electrical conductivity in metal is due to free electron, while in semiconductor it is due to jumping of electron from valence band to conduction band. Student, there are two types of bands. The first type of band is valence band, which are occupied, and conduction band, which are unoccupied. In case of conductors, both type of bands overlap each other. I repeat again. In case of conductor, both type of bands overlap each other. That means there is no energy gap. Also, electron can easily jump from valence band to conduction band because both overlap each other. In case of semiconductor, there is a small gap between the valence band and the conduction band. That is why on increase in temperature, electron from valence band jumps to conduction band and electricity conduction is possible. It is interesting to note that the gap between the top of valence band to the bottom of conduction band is called energy gap. It is indicated by capital E in suffix small g. It is case of semiconductors. Now the third one is insulator. In insulator, there is a large gap between the valence band and conduction band, due to which the promotion of electron is not possible. It is called a forbidden zone. It is called a forbidden zone in which there is a large energy gap. It is a case of insulator. It is a band theory. I repeat it again. On the basis of electricity, solids are of three types: conductor, semiconductor and insulator. In conductor, conductivity lies between 10 raised to power 4 to 10 raised to power 7 ohm inverse meter inverse. In semiconductor, conductivity lies between 10 raised to power minus 6 to 10 raised to power 4 ohm inverse meter inverse, while in insulator, conductivity lies between 10 raised to power minus 20 to 10 raised to power minus 10 ohm inverse meter inverse. Now let us consider magnetic properties of solid. On the basis of magnetic properties of solid substance are of five types. These are: number one is the paramagnetic substances. I repeat again, on the basis of magnetic property, solids are of five types. Number first is the paramagnetic substances. Paramagnetic substances are those which are weakly attracted by the magnet. I repeat again, paramagnetic substances are those which are weakly attracted by magnet. Example: O2, Fe3 positive, etc. Number second is diamagnetic substances. Diamagnetic substances are those which are weakly repelled by the magnetic field. I repeat again, diamagnetic substances are those which are weakly repelled by magnetic field. For example, water, benzene, etc. Number third one is the ferromagnetic substances. Ferromagnetic substances are strongly attracted by magnetic field. Also, their magnetic domains are parallel in one direction, like this manner. I repeat again, ferromagnetic substances are strongly attracted by magnetic field and also their magnetic domains parallel in one direction. Example are nickel, cobalt, iron, etc. Number fourth one is antiferromagnetic substances. Antiferromagnetic substances have magnetic domains parallel and anti-parallel in equal number. Therefore, their magnetic moment is zero. The best example of antiferromagnetic substances: manganese oxide. I repeat again, antiferromagnetic substances have magnetic domain parallel and anti-parallel in equal number. Therefore, resulting net magnetic moment is zero. Example is MnO. Number fifth one is ferrimagnetic substances. Ferrimagnetic substances have magnetic domains parallel and anti-parallel in unequal number. Therefore, they show net dipole moment. The best example of it is Fe3O4. So on the basis of magnetic property, we discussed solids are of five types. These are paramagnetic, which are weakly attracted by magnetic field; diamagnetic, which are weakly repelled by magnetic field; ferromagnetic, which are strongly attracted by magnetic field; antiferromagnetic, in which magnetic domain parallel and anti-parallel in unequal equal number; and ferrimagnetic substance, in which magnetic domain parallel and anti-parallel in unequal number. Student, there are some crystal, or we can say solids, which generate electricity when we applying mechanical stress over them. The electricity produced is called piezoelectricity. The best example is quartz. I repeat again, there are some crystal or substance which when applied mechanical stress or pressure, small amount of electricity is generated. Such substances are called piezoelectric substance, and the electricity produced by such substance are said to be piezoelectricity. Also, there are some crystal or substance which on heating generate little amount of electricity. Such substances are called pyroelectric substance. Now student, let us discuss some important or interesting question answers. Question number 1. Why NaCl appear yellow instead of white sometimes? Student, NaCl appear yellow sometimes due to developing color center in it. Question 2. Name the compound which exhibit both Schottky as well as Frankel defect. It is AgBr. Thank you very much.